Hi everybody, this is Coach Cecil. Today I'm going to be going through lessons 316 and 319. You'll notice that my video is not on, and that's just because there's going to be a lot of document camera writing today, and when I do the document camera and I choose Zoom, because that's the best one to show the video and my face, it tends to lag, and just with all of the information, I don't want the video, basically the document camera, to be lagging from my instructions. I want to make it clear as possible. So sorry, you're just going to be seeing the screen today. So let's get started with 316. I can solve quadratic equations by completing the square or using the quadratic formula is a learning target that we will be using. All right, so right here, guys, with Priya and Han, we need to make sure that we're using the quadratic formula correctly. And so as we see, it is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, then, now we look here, okay, we have 3x squared minus 2x minus 5. And so the a will be 3. Okay, this is our a. The b is negative 2, and the c is negative 5. So we do see that they all input it here. Okay, however, when we look at Priya makes a mistake in line 2 because she uses a positive 2. Notice how she wrote a negative 2 here, the opposite of 2, and then a 2 squared. So she is going to get an incorrect answer because that should be this should end up being a positive 2 out front because the opposite of negative 2 is 2, and then this 2 squared should be a negative. Lynn did a great job here putting the opposite of negative 2. But notice how they did negative 2 and they did not put parentheses around it and then they squared it. Okay? I always tell people this is how you screw up in your calculator because your calculator computes this as 2 squared and then the opposite of that, which is negative 4. When in reality, I'm taking negative 2 squared, which should be a positive 4. So, I cannot agree with Priya because of the mistakes she uses with her negatives here, and I cannot agree with Lynn because of the mistakes that he or she makes right here. So I'm going to agree with neither of them. Okay, so the expression x squared plus 8x plus 16 is equivalent to x plus 4 squared. Which expressions are equivalent to x plus n squared for some number n? Select all that apply. Okay, so I am just going to write these down really quick, and we can take a look at them. Feel free to pause the video if I'm going too fast, and you can kind of keep up with your pencil at home as well. All right. So again, guys, we're looking for perfect squares. So again, what we're going to look at is we're going to look at our c's and see which ones of these are numbers that have an easy square root. Okay, you know what I mean? So by like the square root of 4 is 2. The square root of 9 is 3. The square root of 16, 4. The square root of 25 is 5. So you should be able to do that all up to 12 in the square root of 144 to help you out mentally. All right, and so as we see here, there are two, the 25 and the 9, that are perfect squares there. And so we do know that, hey, what numbers when I multiply them to 25 give me 10, x plus 5, and x plus 5. Since there's two of them like that, I can write it as x plus 5 squared. 29 does not, 8 does not, 9 does. Okay, we see that that is going to be a 3. However, notice here I have a negative 6, so both of these have to be negative. Since I have two of them, it is x minus 3 squared. So the bottom and the top polynomials are the ones that are equivalent. If you need further breakdown, this lady here, she does a great job of breaking down the first two slides and gives just another voice to this in case what I said wasn't enough or you needed some clarification. Okay, different ways to solve it with Elena and Han. And, are they both right? And we see that they are, okay? So the reason we do the perfect squares, guys, is look at Han, all right? You spent last class period doing what Han is doing here, going through the quadratic formula. But something that, some of you might have hit during the AMI day or just in other classes is called completing the square, okay? And so I'm going to go ahead and write what Elena has, this whole x squared minus 6x plus 7 equals 0. And kind of walk you through completing the square, okay? So what we're doing, guys, is we're trying to find quadratics that way I can make this a perfect square, okay, to add up to 6x. All right, so we see here, if we use this one up top, okay, we can see that, that we need a 9, right? Okay, and so to do this, okay, basically he adds 2 to each side so that it is a perfect square. Okay, because remember, if you do it to one side, you have to do it to the other. All right, so I accidentally swiped there, and we'll get back to where we were. Sorry about that. Okay, and so what Elena does is she knows that to get 9, I have to add 2 to both sides. And in doing so, now I can combine like terms. And on this side, notice, hey, I can get to this because now I have this where C has a perfect square and it does add up to this. So now what I'm going to do is I'm going to rewrite this quadratic in factored form of x minus 3 all squared equals 2. Now I write it like this instead of this because we want to get rid of the squared. And how do I get rid of the squared? By doing the inverse operation, which is the square root. If I do the square root, it just drops and it becomes x minus 3. And then remember, guys, in this, it would be plus or minus radical 2. Move your 3 over, and you do get x equals 3 plus or minus radical 2. Okay? And so that's one way how you can solve it instead of using the quadratic formula, especially when x is 1. Okay? And so we see here on this side, Han did use it. Now notice, hey, over here, Elena has 3 minus radical 2. Right here we have 3 plus radical 8 over 2. Guys, both answers are correct. We just haven't got to the unit yet. Again, since we flip-flopped this and did complex before rational exponents, we have not done anything on breaking down radicals. And if you knew that if you broke this down, it'd become a radical 2. So fear not, we're okay with you writing it like this right now. Okay, so technically we can agree with both of them, and even though they look different, they are the same answers. All right, here's another video. She spends 5 minutes here breaking it down even further. I think she does a great job explaining it, and it does great. Okay, and so, guys, here, don't worry about that. Let's go ahead and skip that. We're going to use here, it says solve each quadratic equation with the method of your choice. And so let me just go ahead and write this down on paper because it's going to get messy. And actually, you know what we'll do? Let's split screen this. So that way mistake. Come on now. How about that? Okay. All right, guys. X squared equals 100. All right, that one is easy because we do know that this is a perfect square, so we just square root both sides. What's the square root of 100? 10 and negative 10. Okay. Now I have x squared equals 38. I square root it, and there is no perfect square for radical 38, so it is just plus or minus radical 38. Let's try to get a little closer here. Sorry about that. I am all over the place here. There we go. Okay, so this will be a positive radical 38. Okay, and then a negative, and then a negative radical 38. Okay, notice how my negative was outside the radical, it was not inside. Okay, the next one, x squared minus 10x plus 25 equals 0. Okay, we see here, we know that's perfect square because, hey, 25, all right, what multiplies to 25 when I add them together give me negative 10? X minus 5 and x minus 5. We also know we can write that as x minus 5 squared equals 0. Square root both sides, and I'm left with x minus 5 equals 0. Add 5. And the answer is just x equals 5. Okay? We can do it like that. Or instead of doing this, I was just stuck in that mode, we also could just say, hey, we know that when we look at this, the answer is just 5. Okay? X plus 14 plus 40 equals 0. Factors of 40 that when I add them together give me 14. We know that that's going to be x plus 10 and x plus 4. So we know that x equals negative 10 and negative 4. Alrighty. Now, with the next one, okay, we have x squared plus 14x plus 39 equals 0. So we're going to have to use the quadratic equation on that to solve. Okay, so let's go ahead and solve that. So we know, again, the quadratic equation, guys, so I know that a equals 1, b equals 14, and c equals 39. So we're going to take the opposite of b, so negative 14 plus or minus radical, okay, b squared, so 14 squared minus 4 times a times c all over 2 times a. All right. So you want to do your discriminant first, which is what's inside the radical. So if you have your calculators, you'll want to get them out. And 14 squared is 196. I'm going to have negative 14 plus or minus radical 196 minus 4 times 1 is 4 times 39 is 156 all over 2. So then, guys, we're going to have negative 14 plus or minus, we see here, 196 minus 156. That's going to give us 40 all over 2. All right. We could break this down more, but at this time we will not. All right. So what we need to know is, hey, you can either write it like this, or you can write it as negative 14 plus radical 40 over 2 and negative 14 minus radical 40 over 2. I'm good with either one. Okay, we'll do the same thing, guys, with the last one, but for time purposes, we will go ahead and move along. Okay, and she does a great job solving them here, so if you do solve them, she'll check your answers. And she actually, you know, if you're just dying to know how to break this down, I can show that to you in class, or I can email it to you. But right now, we're okay with this. All right, guys, here's the lesson summary over Unit 16. That kind of breaks it down if you're more of a visual person that just needs guided directions. All right, 319. I can find complex solutions to quadratic equations. Okay, so what we need to ask ourselves, guys, is it real or is it not real? Okay, so is my equation real or is it not real? And the way to find that out is, hey, does my solution cross the x-axis? And if it does, okay, it has real solutions. All right, if it doesn't ever cross the axis, it does not have real solutions, and we wouldn't technically be able to solve it with real numbers. All right, so we see here x squared minus 6x plus 5 equals 0. We know that that can be solved because we have factors of 5 that when we add them up together, we get a 0. Okay, that's going to be a -1 and a -5 because -1 and -5 add up to -6. When I multiply them together, I do get 5. My answer would be 1 and 5. So when asking, is this real or not, it is real. And then 1 and 5 are the solutions. Sorry for the typo there. Should say solutions, not solution. Okay, x squared minus 6x plus 13. Plus 13. Okay, well, looking at that, guys, we know that 13 is a perfect number, and I don't know what we can have there. So it's going to have, we're going to have to use the quadratic equation to solve that. So we do have, let's see, A is going to equal 1, B is going to equal -6, and C is going to equal 13. Okay? So the opposite of B, so 6 plus or minus B squared, so -6 squared, minus 4AC all over 2A. Okay? So now when I do this, I'm going to get 6 plus or minus 36, all right, minus 52, because you should have, let's see, 4 times 1 times 13. That should give you 52 all over 2A. And so then, guys, I'm going to get 6 plus or minus, and it looks like I'm going to get a negative number here. What would that be? 16, I believe. -16 all over 2A. And so my answer would be 6 plus or minus I radical 16 over 2. And I don't know why I kept writing 2A. Just be 2. Okay? So 6 plus or minus I radical 16 over 2. Again, you're going to find out how to be able to break that down. And hey, now that I actually write that, did I multiply correctly? Because I do see, hey, radical, oh, well, I'm sorry. Let's keep going, all right? Because I messed up there. Radical 16, guys. What is radical 16? 4. So hold on, hold the phone here. 6 plus or minus 4I all over 2. Okay, because again, radical 16 is 4, so we can write it as 4I. So 6 plus or minus 4I all over 2. And then, guys, 6, 4, and 2, what can go into all of those? 2. So my real answer then would be 3 plus or minus 2I. All right, I'm glad I caught that before we got too far. And so then that'd be 3 plus 2I and 3 minus 2I. Okay? All right, now on this other one, here we'll do the work right here. Okay, I have a negative x squared plus 6x minus 9 equals 0. To make this easier to factor, guys, we don't want this negative here. So what I'm going to do is I'm going to multiply both sides by -1. Now, why do you multiply by -1? To change my sign. So now I've got x squared minus 6x plus 9 equals 0 times -1, which is 0. Okay? So we know that, hey, this is x minus 3, x minus 3. So my answer is 3. Oh, is real. I don't have an I, and it's 3. Then my last question, -x squared minus 9 equals 0. We want to solve for x squared, so hey, let's move the 9 over first. So then what I'm left with is -x squared equals a positive 9. Okay, change your sign so it's positive. Square root it to get rid of the x squared, so now I just have x equals plus or minus radical -9. How do you get rid of a negative inside? You change it to I. So x equals plus or minus radical 9i. And we know that radical 9 is 3. So it's going to be x equals plus or minus 3i. So it's going to be not real. And it's going to be a positive 3i and a negative 3i. Okay. How are you going to create? So guys, on this, let's go ahead and go full screen, and we're done using that. Okay, creating your own quadratic with no real solutions. Again, guys, you're making one. So if we use the stock quadratic x squared, we see that, hey, even though it's on the line, we're going to have one real solution, and it's going to be real solutions. Okay, and so we see multiple ones here. You know, even if I have y equals a negative x squared. Okay, we're gonna be crossing. All right. Now the easiest way to show a line that does not have real solutions is, again, it's not going to cross this axis, and so the easiest one is that we just change that y-intercept and we just move it, guys, off the axis. So see, now I just moved it up, and we see here that does not cross. And it is a no solutions. How would I say, hey, how could I manipulate this green graph? We'll just go ahead and eliminate these to show you the green graph. We're here. How can I manipulate those to show one with real solutions? Change the direction of the graph. And now it's crossing the line twice, and it does have real solutions. So this is a fun way to just to play around with graphs and list, your own numbers here just to see. And that doesn't work because I did a plus, but we can see here, if we zoom in on this graph, no real solutions because it doesn't cross. Okay, if I did want it to cross again, the easiest way to know if you're making your own equation, if you do one and you're needing reals and it's not real, change the direction of the graph, and that will flip it, and then it will go across. Okay. Here is a synthesis on everything that we have done. I know this is very quick. I kind of went over it pretty quickly, but again, guys, you have a really good understanding of the quadratic formula. So this is more of just an enrichment activity. So this should give you plenty of time to do your classwork and to prep for the test, which is next lesson. So have a great day. Ain't nothing to it but to do it. And please reach out to me if you have any questions.